So who's doing introductions this time around, Jerry? Is that you or me?
Well, let's just introduce ourselves, right? So I'm Jerry Ola. I'm one of the product managers here at Ekahau. And Joel, who are you?
Yeah, I'm Joel Crane, and I am the technical training manager here at Ekahau. And so Jerry and I get to work together a lot, which I really like because I don't know, I like Jerry, and it's pretty fun to do webinars and stuff with him. And so I think we're pretty stoked to bring you this webinar topic today. I could talk about housekeeping items. That sound like a good idea? I'll talk about housekeeping items.
That'd be great.
So a couple things to keep in mind. First off, Jerry has hit the record button. So we are recording on this webinar. So this will be posted to our webinars page, and we usually say within 24 hours, but we've got a team of awesome marketing people, and they usually get it posted really quick. So just keep an eye on the webinars page, and you can watch a recording of this as soon as we get that posted. Also, a couple things to keep in mind, involving the audience and questions and things like that. First off, if you want to chat, if you want to just kind of drop comments and chat with other members of the audience, you can use the chat tool. So there is a tool in Zoom labeled chat. And if you go in there, make sure that you send it if you send it to just all panelists, only Jerry and I will see it. But if you send the chats to all panelists and attendees, you guys can chat. You can just, send comments and things like that. And Jerry and I will keep an eye on that. And if we see a good comment or something, we'll probably bring it into the conversation if it's a good time. But go ahead and use that. If you have questions for Jerry and I, though, if you have a specific question, something you want to ask us, use the Q&A tool. And so do we have upvoting and downvoting turned on the
Yes,
Q&A tool?
I did enable it. Yep. So yeah, you can go ahead and you'll see the little thumb up kind of thing that you can click on. So if you like a question that you see submitted and you got the same question, go ahead and thumb that up. So that way it puts it up to the top of the list. We'll make sure we get to those.
Perfect. Yeah. So if you put something in the chat, there's like a 50-50 chance that we'll see it depending on how busy things are. But if you put it in the Q&A tool and then other people can upvote it, that's just a really good way to ask questions. And so I would encourage you to do that. So are there anything else I'm missing? We talked about chat, we talked about Q&A, we talked about recordings. That's it, right? I think we're ready to get started.
Yes, let's go ahead and dive into this topic on the real cost of bad Wi-Fi. So hopefully everybody can see my screen okay. Let's go ahead and kind of run through, what this topic is all about. So, I think everybody on this webinar is well aware that Wi-Fi is kind of everywhere nowadays, right? You've got, warehouses relying on Wi-Fi, hospitals depending on it, hotels, really need to start offering good Wi-Fi to their guests. And then even in, things like education, we're seeing more and more things going to these digital routes, online testing, all these types of things for homework assignments and tracking all this kind of stuff. So Wi-Fi is becoming not so much just even everywhere, but it's becoming more and more critical, and people are depending on Wi-Fi more and more. So what happens when bad Wi-Fi happens in these same types of environments? Well, in a warehouse, things are going to grind to a halt pretty quickly, right? If we can't update our inventory systems and can't track things and ship things, things come to a halt pretty fast. Hospitals, as Wi-Fi and these kind of communication things become more and more critical, hospitals can really start to struggle from, patient satisfaction to hospital staff communication. And then in the hospitality space, your hotels, are you going to return back to a hotel that you can't consistently get onto the internet and, get work done while you're traveling? Student satisfactions, test scores, things like that could be impacted as well in the education space with a unstable Wi-Fi connection. So Joel, any comments on that?
Yeah, definitely. I mean, so you and I, we travel a lot. In fact, I rolled in late, like at midnight last night. But you and I, we travel all over the place all the time, and I definitely choose a hotel based on how good the Wi-Fi is going to be, because you never know, when you're going to be presenting a webinar or something, and we need good connectivity. And so I kind of have a little mental list of which hotels have good Wi-Fi and which hotels don't. And if a hotel consistently has bad Wi-Fi, I avoid that hotel because I need it to do my job.
Yeah. Yeah, I don't recall off the top of my head. I'm sure somebody might know it. If you got it, throw it in chat there. But I remember there's a website out there that actually exists for just tracking, Wi-Fi performance at hotels and kind of rating a hotel based on, their Wi-Fi and if it's a good experience or not. So, it's become that critical now where, yeah, people are actually, looking at these kinds of things and judging, okay, there's 3 hotels in this area, which one has the best Wi-Fi, and I'll pay extra money or, make sure I return to that place if I know that is going to provide a good, consistent experience.
Yeah, absolutely.
You said my audio is a little.
No, I don't know. I think, yeah, I've got a couple people. I don't know. You are loud and clear here, and so I would expect that mine might not be so great. Yeah, Zachary Wheat, he's not seeing any issues, and so I think we're okay. So yeah, if you're having audio problems, I would recommend just checking your connection. Try to plug in an Ethernet cable if you can. Hey, this is the cost of bad Wi-Fi, right? I mean, you might not be able to enjoy a stellar A+ webinar from the Ekahau team if your Wi-Fi is not great. So yeah, see, look at that. I just tied it right in right there. It's pretty good, huh?
So ironically, yeah, on that note, the last thing I did before I joined the webinar was I switched my laptop over to a wired Ethernet connection. Even though I know I've got pretty solid Wi-Fi where I'm at, when I'm doing critical things like delivering a webinar to our awesome audience and attendees, I want to make sure I deliver as good of a quality experience to you guys as I can. So I actually am tied to a cable right now just for you guys. So I hope.
Yeah, and then there's me. I'm using a mesh. I've got one mesh hop to get back to my wired infrastructure. So fail.
This will be a
Jerry's
good
all committed and I'm not. Yeah, exactly. Yeah.
It's a good comparison. So every time you hear Joel drop out, you can correlate that to bad Wi-Fi.
Perfect.
All right. So yeah, let's get into this here. So here's our agenda for today. We're going to focus on these three main topics, and hopefully you guys find some value in these. So the first thing is bad Wi-Fi and what is the real impact on a business or an organization. It's beyond just an inconvenience nowadays. In the past it was just kind of like, oh, we got Wi-Fi or we don't. But we're going to talk about what is the true impact there. And how much does bad Wi-Fi really cost? There can be a dollar association to it, but there's also a lot of other things that we're going to talk about, that we can correlate to good or bad Wi-Fi. And then how to avoid bad Wi-Fi, right? So we're talking about all this bad Wi-Fi, but how do we avoid those pitfalls of bad Wi-Fi? All right, so yeah, why does bad Wi-Fi exist today? Well, really, this is kind of the the marketing spiel that we see everywhere. Is it's plug and play. We've heard those kind of tech terminologies. We've got all this AI stuff, and you just plug it in, and it self-configures itself and optimizes itself and fills holes for you, and optimizes the RF and the air and all this kind of stuff, right? And that's kind of the story that we're being told. But as wireless engineers and people working in the space, we know that's not always the reality, right? So it's not always plug and play, right? We've got more and more complexity being put onto these Wi-Fi networks. There's more demand being put on them for things like latency sensitive applications and usage like voice over Wi-Fi. We have things like location-based services that are utilizing the Wi-Fi signals. We've also have a lot of capacity challenges that we're facing. And then interference, we're seeing more and more wireless type technologies operating in the same spaces as our Wi-Fi is. So yeah, let's kind of talk about that then. What is the reality of things? So we talked about the kind of marketing spiel and story that we're being told when we buy this equipment. But if we just deploy it and don't do any kind of forethought or planning or engineering to this, and we just plug everything in, this is really the reality that we're kind of left with. We see things like coverage holes, roaming issues, just inefficient use of the spectrum. Packet loss, channel overlap, capacity issues, all these kind of things can be correlated to, insufficient planning and really, not properly designed and engineered. So yeah, bad Wi-Fi, some of the things that we can correlate to this is things like, starting on the dollar value side, potentially lost revenue. And that's a very, real thing, right? As we become dependent more and more on Wi-Fi, if your business is solely, using things like iPads for your checkouts and all you have is a Wi-Fi connection to that iPad, and the Wi-Fi goes down or drops out occasionally, and you've got to, do some troubleshooting, reboot everything. That's all potential lost revenue during those downtimes. And also, what does that do to the customer impact if every time they go to your business and it takes a while to check out because there's all sorts of troubleshooting that has to happen, or it takes a long time to process a credit card. All these kind of things can impact things like customer loyalty. There's been statistics that show customers spend less time in a business that doesn't offer Wi-Fi to their patrons, right? So you have some businesses that embrace that kind of free and open model, and they provide free Wi-Fi access to their customers. And when they do that, they actually see the customers spending more time in their store, right? There's incentive for them to hang out in the store because now they have Wi-Fi connectivity. And if it's good Wi-Fi, they may even spend more time than if it's just, you give them 1 megabit a second or something, and it takes them a while to pull something up. They're going to be happier about, having a good connectivity experience in their, your organization or company, providing that for them. Same with, if you think of it, from the other side of, beyond Wi-Fi, what are some of the other things that are kind of expectations from a business, restrooms, for example. And if you go in there and, maybe they offer a restroom, but, it's way in the back corner and it's in this dark area and, it's dirty and, those kind of things, are you going to really appreciate that and want to come back to it and do business and do more business with that organization if they can't even provide something that's, typically expected of the customers, something as simple as like clean restrooms. So same with Wi-Fi, we're expecting good Wi-Fi to, not only to your employees, but also to your customers that are shopping at your business. Also lost productivity. This is one that I feel like is more overlooked, right? So we could lose productivity with this of, employee satisfaction. We're seeing employees, when they're in a work environment, they're expecting Wi-Fi, not just so they can get on Facebook and social media, types of things while they're at work, but just so that they can do work, right? And just be able to have some freedom and flexibility at work of not having to worry about, okay, if I leave my desk and don't have a wired connection, I don't know if I'm going to be able to, jump on a conference call and be able to, people are going to be able to hear me, or my audio is going to be breaking up, those kinds of things. So we need to make sure that, the employees have that kind of freedom and ability to move around the office and not have to worry about if the Wi-Fi is going to work or not in certain areas and certain conference rooms and certain parts of the building. And then, just, making sure your employees are happy by, providing that good connectivity to them.
We've all gone to a conference room or something like that, somewhere, right? And tried to jump on a conference call, and we had to use Wi-Fi to conference somebody in. And pretty soon you have 12 people, you may be including your CEO or your president, that are waiting on, this issue because we can't get connected to the network or something, or the audio quality is just bad because of poor connectivity or something like that. It's scary to think about how much that costs to have 12 people, especially when you start talking about, somebody in upper management, somebody like that. Their time is just so valuable. It's scary to calculate how much money you can lose. I mean, that makes an $800 AEP just seem like, like a no-brainer, right? To fix that problem.
Yeah. All right, so let's talk about, how much does bad Wi-Fi really cost then? So we actually put together, this is kind of, we're debuting it, I guess you could say, on this webinar. I'm sure I'd be very surprised if anybody has seen this yet because we haven't promoted this yet, but you guys can be our beta testers for this. And check out roi.ekahau.com. This is a new kind of landing page that we launched recently, and this is an ROI calculator for trying to calculate out what is the return on investment of good versus bad Wi-Fi, and if you have bad Wi-Fi, what does that do? So things like what is the adding up costs like time spent troubleshooting, downtime, what does that equate to from a lost revenue, lost productivity, lost hours, and then having to remediate that, right? So paying the somebody to come back on site potentially multiple times for things like moves, adds, and changes, all those kind of things add up over time, right? So let me go ahead and pull this up here and see if I can we'll do a quick, just kind of mock run through of what this actually looks like to do this calculation. So I'm gonna go ahead and see if I can pull this up here. Let me go out of the full screen mode here. Get this to exit full screen. And let's go ahead and pull this ROI calculator up here real quick and run through this. So I've got my ROI calculator up here. I'll make this full screen. Hopefully you guys can see this okay. And I'm just going to run through, an example. So let's take education here, and we're going to say in the education organization that I work in, our approximate revenue here is in the 5 to 25 million. And we've got a frequency, the frequency of our Wi-Fi problems. It's not real, we don't have a ton of problems, but, they're definitely come up. So about 10% of the time, we have some downtime, we have some complaints. People complain about the Wi-Fi being slow. So it's not perfect, but, the majority of the time it does work. And then what is the impact on things like doing business, right? So within the organization, what we're looking at here is, if the Wi-Fi goes down, is it just an inconvenience, or is this like, we can't process a transaction in like a retail environment, those types of things. So we can look at, from a percentage standpoint, what is the impact on the overall business piece of that? Does it just shut everything down? Does everything grind to a halt if the Wi-Fi is not working? Or is it, we can continue as going, but, things are maybe a little bit slower, a little less convenient. So in this case, I'm going to say the not much, the 40% mark there. And then, number of employees there, that's part of this organization. So we're going to say we've got the 101 to 999 one there. So plugged in some values. And based on all of those selections there, we're saying here for this industry, we've calculated that.
Hey, Jerry. Hey, sorry. I'm gonna let you finish. But apparently we're having that Zoom issue again where your face is massive, which is fine. I don't think anybody really minds that your face is massive. But the real problem is that your screen is very tiny up in the corner of people's screens. I'm not having that problem. And so I don't know. Did Zoom ever give us a way to fix that? Or are we still dealing with that?
Let me try and see if I share this a different way.
Says your face is really massive.
Well,
so,
that's just a problem in general.
Go.
I don't know if we can get Zoom to fix that. I think I just have a massive face.
Oh, okay. I'll put in a feature request. Can you decrease the size of Jerry's face?
So I just stopped my sharing and reshared the window a different way. Did that help at all?
Okay. Everybody says Phil says fixed. Andrew says downsizing. No, we're not downsizing. Seth says just double click the screen share. Good. And Christian says there's a swap button. And James is not seeing a huge face. And Saeed says, yes, all good. So sweet. We're probably good to go. So if you're still having problems, I'm sorry. We tried. So
well, and if you're having problems, just pull up a web page, go to roi.ekahau.com. And all I wanted to do was show you an example of, what that looked like. So yeah, if you are still having problems with it, roi.ekahau.com. That's the page I'm on. You can plug in your own values. And I just want to show you how you can spit out these results. And yeah, really what this is then, we get the summary of the results here at the bottom. It's telling me bad Wi-Fi cost summary as far as, lost annual revenue, but then also breaks out, how many hours of lost productivity can be attributed to the bad Wi-Fi based on those selections. And then what you can do, plug in your email address there, and we'll actually shoot you some more details about those calculations, how we came up with those, as well as some industry specific things that we have to offer to help with that. So yeah, check that out at your leisure. Try not to get too bogged down into that through the rest of the webinar here. But yeah, check that out, and hopefully you guys find that helpful. If you need to convince your boss on why we need to improve the Wi-Fi around here, and what from an ROI standpoint, buying some tools and doing a proper design could do for the organization, hopefully that'll help kind of justify those costs. All right, so let's go ahead and see if we can break this one more time and switch back over to the actual presentation deck here.
Back to the slides.
Yeah.
It's a bold move. It's a bold move, Cotton. We'll see if it pays off.
Okay, that should hopefully be coming through now.
So I got a question here in the Q&A that I think this is probably a decent time to answer this one. The question is, how do you handle good Wi-Fi that has a bad reputation among end users due to client issues like driver versions? Let's say the end users with bad drivers are contractors and not likely to follow advice on upgrading drivers. Oh man, that's killer, isn't it? How do you handle client side problems? Your infrastructure is good, your design is good, your network is good. What do you do?
Yeah. Well, I mean, I think there's a lot of things, there's a lot of parts in that, right? Is it a bad just design where it has a bad antenna in it and it can't hear very well or transmit very well? You know, we can factor that into a design and design, you know, if that is a critical device, you know, we can certainly factor that in, right? If it's a chipset issue and, you know, they just don't support certain features and things like that, yeah, we kind of have to draw a line in the sand and say, okay, you know, 5% of our users use this type of device that has some known issues working with this certain, you know, technology or this certain type of PHY type or, you know, certain amendment or something like that. You know, we kind of have to draw a line in the sand and do what's good for, you know, for the greater good, right? Of, you know, 95% of our users are going to have a better experience if we basically use this feature set, but these 5% of users are not going to be able to have access to Wi-Fi, or they're going to have a bad experience. That's the way I would take it.
And that is just a tough question. I mean, that is a hard one to answer. I don't know that there is really a good answer for that one. I mean, if you can implement some kind of processes or policies, you know, where, where maybe you don't allow anyone to open a support ticket. This is just me like dreaming stuff up here, probably not realistic, but if you could, you know, not allow people to open a support ticket until they have verified that they have the latest drivers on their laptop, you know, if they're a tech savvy kind of contractor, maybe there's something like that you could do.
Yep. So yeah, on that note, that's a good transition. You know, what is bad Wi-Fi? So bad Wi-Fi could be things like, yeah, devices having problems connecting to the network. It could be, you know, they're connected, but certain applications don't work very well over Wi-Fi, choppy video, dropped calls. But yeah, then we talked about things like lost revenue and impacted things to, you know, things like healthcare services due to bad Wi-Fi. So on the flip side of that, you know, what is great Wi-Fi? Well, that's pretty easy, right? It just works. When we have good Wi-Fi, you know, it doesn't matter what application you're running, what device you're using, things like that. It should just work. But yeah, as you're pointing out, there can be situations where, you know, no matter how good the infrastructure is, we could have bad devices that, you know, just don't work properly on the network. And yeah, to that point as well, you know, the other piece of that, and we'll get into this when we get into the demo, is, you know, we need to make sure we factor those critical devices into our design. And I like to think of it as, you know, what is the least capable, most critical device on the network? And in like a healthcare environment, you know, that can be very drastically different from something like an education space and a bring your own device type space, where in a healthcare space, you might have very critical life-saving type devices that, you know, the criticalness is very different than a BYOD, you know, hospitality or education space. So yeah, let's talk about, you know, what Echo can do to get us from that bad Wi-Fi to the great Wi-Fi. So this is really the life cycle, and I've even seen some similar type things in chat here already about, you know, what is that kind of process, that life cycle to getting good Wi-Fi. Really, there's three main steps, right? First, we need to create a plan. We need to figure out, you know, what are we designing this network to do? What are the devices that are going to be on the network? What are the applications that they're going to be using on the network? Once we know all of those kinds of parameters, we can create a plan. We can figure out what's the right type of access point, the type of antenna, where should we place these access points, how many access points we're going to need, and then we can validate that. Once we've created that plan, we validate the plan, make sure that it meets all of those requirements and is going to satisfy those, and then we deploy. And then once it's deployed, you know, we're not done, right? We're going to be continually monitoring that, troubleshooting things. As we talked about, you know, things like capacity changes, interference can be introduced, things like that. So it's not just a one and done type of a thing. You know, this is a iterative process, and we're going to be fine tuning things as we go along. We may need to, change some settings. We may need to adjust, you know, even the locations of access points or add access points further down the road. But if we do the proper planning up front, that should buy us, a significant amount of time before that's going to need to happen if we've done some forethought and planning to future-proofing that, if you will. All right, so what does that look like? So using the Echo Site Survey application, we can use that to do these predictive designs to design reliable, high-capacity Wi-Fi networks. Then we can utilize things like the Sidekick to validate and understand and optimize the Wi-Fi performance, taking real-world Wi-Fi measurements. And then lastly, we can identify and remediate Wi-Fi issues on the spot using that spectrum analyzer and the Wi-Fi radios on the Sidekick to see what exactly is happening in the RF environment. All right, what do you think, Joel? Should we stop talking here and going through some slides and show what that looks like in the Echo Site Survey application?
Oh, I'm not going to stop talking. I'm going to continue talking. But yeah, we can depart from the slides and we can kind of move into I don't know, a little bit of live demo. And Jerry, while I'm demoing stuff here, feel free to pop in with comments and, oh, hey, try this and stuff like that. So. Cool. So what we want to do here is what we have done is we have used the predictive modeling tool in Ekahau to design. Well, this network isn't really designed. I mean, if some of you are probably looking at this going, oh boy, Joel, what did you do here?
So if you notice, Joel is not wearing his hat.
Oh no.
No, it's intentional, right? Because
right, yeah.
The hat, you wouldn't be allowed to wear the hat with what we're going to go through here.
Yeah.
You can't see that on my camera. It says on the inside of the Echo hat, I will never design bad Wi-Fi. So Joel had to remove his hat for today's webinar because he has done some pretty bad Wi-Fi design here. We'll call it design because
this isn't even really a design, right? And so let's take a look at what I've done here. And so basically this is just kind of simulating a non-design in Ekahau where I've brought in a floor plan. And I drew in the walls and stuff. And then I just threw some APs around in the hallways, which is, if you're kind of in a no design scenario, this is pretty typical of what you're going to see. You're going to see a bunch of APs lined up and down the hallway. But despite just having all the APs up and down the hallway, there's colors everywhere, right? And so, I mean, Jerry, that usually means there's a lot of green, and green is good, right?
That's right.
So this should be good Wi-Fi. I mean, this should work, right?
Yeah.
It's just Wi-Fi.
Yeah, I mean, it looks like you got coverage everywhere, right? So, there's a couple of, corner spots that might be, might not have connectivity. But, what do you think? I think this looks like a good design. Everybody on the chat think this looks like a solid Wi-Fi deployment here. If we go ahead and just, put these APs in the hallways and plug it in, call it a day.
Yeah, I mean, what? Well, hang on. Well, Nick doesn't like my design or not non-design. He doesn't like my Wi-Fi deployment. I don't know why. So yeah, I don't know. I'll have to talk to Nick about that later and see what I did wrong here. But so as we're looking at this, okay, so let's think about what we did here. We just took a bunch of APs and we put them up and down the hallways. Because why do we do that? It's easy, and it seems like that's the intuitive way to do things. It seems like, okay, well, the hallways are the center of everything. That way the Wi-Fi signal strength, because it's all about signal strength, right? Can get into all the rooms, and that should work. That should work just fine. But as we start to look a little bit closer at this, well, let's think about first, what is good signal strength, and what kind of signal strength do we actually need to have quote unquote good Wi-Fi? Now, the level of signal strength that we're going to provide, if we're thinking about intentionally designing a network, is we need to think about, well, okay, well, what is that level of signal strength? How much signal strength do we want to provide? Now, if we were doing some kind of design where we were just maybe the applications that we're supporting, let's say we're doing a warehouse, and the applications that we're supporting are just like some barcode scanners. And they're pretty fault tolerant. They just need to transmit a barcode every now and then. No big deal. We don't necessarily need rockin' good signal strength everywhere for those barcode scanners to work well. But what if we're doing voice over IP? What if we're trying to convey the sound of somebody's voice over an IP switch network, just like we're doing right now? In a case like that, we really don't have room for faults there. We don't have room for a device to have to try to retransmit something. We don't, we need to be able to transmit something the first time and have it get there, successfully the very first try. We can't have things retransmitting all the time. So we have to think about, okay, well, what is a good level of signal strength to provide? And so right now, if we look at, I'm gonna draw on the screen a little bit here to help you guys see. Down here in the corner, if we look at the legend for what we are currently providing, we are currently providing a basic connectivity everywhere. And so the level of signal strength, everything that's colored, is going to be negative 75 dBm or better. Now that might be okay for, some basic light messaging. That might be fine for transmitting a few barcodes here and there. But for voice over IP or voice over Wi-Fi, I don't know, Jerry, is neg 75 dBm, is that going to cut it at all? Is that even going to remotely cut it?
No, definitely not. And in chat here, I think there's some good points about secondary coverage too, right? And I mean, that's kind of what you're talking about. How could we visualize that here? I'm thinking, network health, network issues. You want to maybe just flip over to that real quick because, yeah, right now, all we're looking at is primary signal strength. But if we want to make sure these devices, if this is designing for things like mobile devices and we need to make sure these devices can seamlessly roam, look at all the areas where we're going to expect to see roaming problems, right? So all these areas in yellow are indicating number of APs being an issue. There's only one access point audible in any of the areas where we see yellow. And even at that, it's a potentially a pretty weak signal to begin with because we're only designing for a minimum of minimum of negative 75 everywhere. So yeah, I mean we're really stretching things out here from a coverage as well as a secondary AP standpoint.
Yeah, it's just this is a very fragile deployment. It's very, very fragile. And so, Jerry, I'm thinking maybe the first thing we should do is let's actually set some proper requirements here. And let's think about, okay, well, what kind of clients are we going to have in this building? Now, I happen to know that this building is a college dormitory. And so I don't know, is basic connectivity going to be enough to support a bunch of wireless devices in a college dormitory? Are they going to just be doing some light messaging and scanning barcodes? Is that what the network is going to be used for? I'm going to say no, absolutely not. This is probably going to be a pretty big mixture of, I'm thinking people are watching Netflix, people are playing Xbox on, probably on Xbox Live. People are running around with Nintendo Switches. Maybe even sometimes people have MacBook Pros and they're actually doing some work, I mean, it's a college dormitory, we can't expect too much out of it here. So I'm going to say that negative 75 dBm, a basic connectivity profile, that is probably not enough. That is probably not enough to do what we need to do. And so I think the very first thing that we need to do is we need to set proper requirements. What do you think, Jerry? Should we, is setting proper requirements the route that you would take here?
Yeah, let's start with the coverage approach, right? And we'll kind of work our way through it as we go through this demo. But yeah, let's start tailing this up. And actually, I forgot to ask this while we were going through the project here. We talked about the moves, adds, and changes, right? And I'm curious to ask the chat here, do you see a typical in your environment, trying to get a good idea and gauge of, when you need to have somebody come back on site and add an access point, maybe move an access point. So let's say as we go through this, we figure out, we need to add some more APs and we need to move some APs out of the hallways. What is the cost typically associated with that? Kind of on a per change, per move, per add, that you need to do. Do you guys have typically like an average you expect to, that to look like? And we'll kind of tally this up as we're going through and making this design be proper.
So Steven says $500 to $1,000 per drop. And so maybe we split the difference and say $750 per drop based on that. Seems like kind of just a nice.
I think it's going to vary, obviously, quite a bit depending on the vertical that you're in, whether it's a warehouse or a hospital. There's all sorts of things that can vary on this. But I just wanted to start getting some numbers here in chat, to see how much that can vary depending on the environment that you're in. So yeah, especially if you have these kind of these per drop kind of costs. What are the verticals that you're in that you're typically paying these kind of things, so we can get some gauge on that.
Yeah, Maxim says around $2,500. Michael says $250 per single drop. Ryan says $1,000. Andrea says $500, but with equipment and licensing, he's talking about more like $2,000. Zach says in regular offices, we figure $500 per drop. I think that sounds like a pretty good number. What if we identify that as our number? We take Zach's on this. It seems like a good middle ground, and it is going to, Lee says 300 to 700.
And that's kind of the environment that we're using in our demo here. I would say it's more equivalent to an office enterprise kind of environment. So yeah, we'll use that 500 number as kind of the baseline for that. And I'll try and keep a little running tally here as we go through and make these remediations.
And just for context here, for everybody, and this is good for me too. Jared says the hospital space can be $2,000 to $3,000 per drop because of, HEPA and stuff like that. Like it just some of these environments, it adds up. It just gets really tough. So we're kind of taking an easier one here, but I'd say it's going to depend on a lot of different factors. And so, so Jerry, since you're running the tally here, what do you want to do first? Do we want to flip this over to some more reasonable requirements and then kind of look at what it's going to take to remediate this network?
Yeah, and I think we can keep this interactive with the audience here, and what would you guys recommend for let's first start with the coverage requirements and figure that out first. What are we designing this network for? Right now it's set up for basic connectivity, right? So let's pull up the basic connectivity and you can see the requirements there, and starting with signal strength at -75. What are some of those requirements? I think a common starting point, Joel, if you want to flip over to the voice and data, I think that's for nowadays type Wi-Fi performance and requirements to provide good redundancy. The voice and data is a good starting point. See if the audience agrees here. But you can see the metrics there that we're looking at, and certainly a big increase on the signal strength, but also in number of APs. We're looking at having at least 2 access points at -75. Does that look pretty good? I see increased SNR.
I agree. Yep, William, I agree with you wholeheartedly. Let's increase SNR to set to 25 dB. I don't necessarily think that we need to do that in this do this in this environment. 25 dB, I agree with, but signal strength, I see -65 is pretty common as well. I'm going to leave it at -67 unless, I don't know if that Fabiano says to go ahead and do -65. Should we bump it to -65?
Let's do it. Audience is driving.
All right.
This, so yeah. We're designing this to audience requirements.
Yep, I see -65 for voice, and I'm going to say voice over Wi-Fi is a distinct possibility here. Dan did an office at -60. Wow, ooh, that's hot. But hey, you know what? If that's what you need to do, and that's what you need to do.
What about number of access points?
Yeah, I was just going to say, okay, so just for if anyone's unfamiliar with this particular requirement and exactly what this one means, this says how many APs can I hear at any given location above a certain signal strength. And so this says at -75 dBm, I want to be able to hear at least 2 APs at -75 dBm or better. So does anybody have any recommendations for, I don't know, for a mixed voice plus data environment, what you would recommend for the number of access points audible at any given location on the map? We might just leave that one there. I'm not seeing any comments about it, so I think we'll just leave that one there. And then finally, the last one that I like to talk about is channel overlap. This one helps us avoid stacking up a bunch of APs on the same channel. As you probably know, Wi-Fi is half duplex. Only one thing can talk on a channel at a time. APs are more like hubs than switches. That's the short of it. And so this says, okay, we want to see a maximum of 2 APs sharing the same channel at -85 dBm or higher. So that keeps us from having a bunch of APs on the same channel. Doug recommends 3 APs. What do you think, Jerry? Should we bump it to 3, or do you think, or for number of access points, I believe is what he is referring to?
Yeah, so I think for now we'll stick with the 2. I think 3, especially if you're going to be doing real-time location services, RTLS, that's where the 3 comes in. I haven't seen the 3 requirement too much for voice, so let's stick with that for now. But yeah, there's certain, certainly usage scenarios that will call for that.
Yeah, absolutely. Cool. Awesome. So, Stu has some great comments in the chat. I'm not going to regurgitate. Just go read what Stu said. Stu is one of our good friends. So cool. We've got our requirements set. And so I've drawn an area here around our building. And so I'm actually going to change the requirements in that area by editing it. And I'm just going to flip it over to our voice plus data requirement set that we just reviewed and made some tweaks to. And so as soon as we do that, okay, now it's very clear that there are some major deficiencies with this network. We've got everywhere that's gray is where we are failing our coverage requirement. That's anywhere that's below -65. So we've got lots of coverage issues, these corner rooms, things like that. If we go look at the network health visualization is just going to tell us whether we are passing or failing those requirements that we just defined. Yeah, it's not good. I mean, this network is an absolute mess. And so we really we're going to have to do look at the specifics, which requirements are failing. I'm going to switch over to network issues And we can see here that anywhere that's yellow is where we don't have enough APs. Anywhere that's red is where we just aren't meeting our coverage requirements at all. We have no good coverage there from those requirements that we just set. All right, Jerry. So what do we want to do next? What's the next step?
Yeah, so let's start remediating this, and I got a spreadsheet going here, and we'll tally up the changes and everything. So let's say we've deployed the solution now. Obviously, this is all just simulation here, but let's say we actually did in reality deploy this solution, and now we're going to be hearing complaints from users in all these grayed out areas, right? All these areas that are in gray are not meeting.
Whoa, I thought it was me, but it was Jerry. Well, I guess I will go it alone here. I pulled up a terminal and I was like pinging things out because I thought it was me. So, hey, Jerry, are you back? What a loss. Jerry down. Okay, well, that's okay. The problem is we were going to tally all the differences here. So,
I'm back.
Oh, Jerry, you're back.
Sorry about that.
Hey,
I
thought
it was a Zoom crash. I swear it wasn't my Wi-Fi.
Yeah, I was going to say, I thought you had an Ethernet cable plugged in and I'm the one using like a janky mesh hop to get back. Okay. All right, good. You're back. I started pinging Google and stuff because I'm like, mine went down.
Went into troubleshooting mode right away.
I immediately assumed that it was me. I don't know if anybody saw the look on my face, but I was like, oh, shoot.
Yeah.
All right, awesome.
Just to summarize, so right now with our non-designed solution, we've got 6 APs, right? So that's our baseline. That's what we're starting with to do all our remediation from, and we're going to add up these, try and add up these costs as we go. So yeah, what would you do, Joel, on this, starting from here?
So one thing, this is totally off topic, but Christian said he made a joke saying that you're using a 10 megabit half duplex adapter. It's literally just out of reach, but Christian, no joke, I have a 10 megabit half duplex adapter sitting over here. So, okay, anyway, back to the webinar. So the first thing I'm going to start doing, Jerry, is I think we need to move APs out of the hallways. And so should I just start moving APs and you want to just count how many APs I'm going to move and then we'll add some more to fill in the gaps and we can count those as well?
Well, let's see. How would we do this in the real world? I would say that's not the standard approach, right? So if this is what you inherited, what I would expect a customer to start doing is start throwing more APs at it, right?
So you want to what would a bad approach be?
Yeah, exactly. Or what's the typical kind of approach? That's the most common scenario that I see is, okay, we've deployed this mess. We've got users complaining all over the place. How do we fix this? So now we start throwing APs at it, right? Where are we going to put the APs? Well, we're not going to put them, necessarily in the rooms where the users are. We're going to start put more in the hallway. Right?
I agree. So I'm just going to start adding. So I'm going to add one to the hallway here. And then we'll do another. So there's 2 that I've added. I got to get this corner somehow, but we want to keep in the hallway because that's when cabling is easy. So I'm going to add one here. So I have added 3 APs now. Let's do a 4th AP. We should probably do one here in the lobby. So there's a 5th AP. We'll do a 6th one over here. This is a counting game. Yay, fun. 7 right here. Oh man, those are like really close together. And there we go. And so now I have added 7 APs to this environment. And have we fixed the problem, Jerry?
Well, it looks greener, right?
It's more green.
We've got more signal, but yeah, let's go ahead and take a look at things like network health, network issues. Do we make things better?
So network issues, how did we do? Well, I'm going to run the channel planner again, and so we can try to sort out this mess of channels. So we'll at least do that. So how are we doing from a channel? Ooh, man, we've got so here's what we're failing now. So we have made our signal strength problem a little bit better. We've improved on the signal strength issue, but what we have not improved on. I was going to say, but look at the signal to noise ratio, how we're failing that all over the place. Yeah. And also look at our channel overlap, how now we have tons of channel overlap. And this is in 5 gigahertz, by the way. Really, really bad. So what did you want to look at, Jerry?
Well, I was just going to say, we've basically solved one problem of not having enough signal strength and not having enough secondary APs, but now we've introduced a whole other more complex problem of, channel overlap issues, right? So, plus we still have SNR issues. We still have signal strength issues because we're not reaching all the way to those corners placing with the current AP placement.
Christian says this is the best comedy show he's seen in weeks. I don't know if that's a compliment or not, but
I'll take that as a compliment. I don't know.
Yeah, we'll just assume
So that's what we guarantee with these webinars. You know, even if you don't learn anything, as long
you'll
as
be
you're entertained,
entertained.
I call it a success.
So Jerry, so how long do we want to go down this road of just like horrible improvements before we start actually talking about like how we can improve this and make it better?
So where I'm at so far is we've done 7 ads, and you know, we're talking $500 per ad. So that's $3,500 right there that we had to spend. Not not counting the additional APs that we just paid for. Plus, there's all sorts of costs that are hard to quantify. Of, well, when we first planned this out, we only needed so many switch ports. Now we need a lot more switch ports, so maybe we needed buy another switch, and we didn't size that out properly. So that's all can start to really snowball and add up. But just in the having somebody come back on out on site, we're at $3,500 in addition that we didn't account for in the beginning of this project.
Yeah, and maybe.
And we haven't fixed the problem, right? We've done is spent $3,500 on this and made the solution worse, right?
Yeah, if I'm remembering correctly, we started with 7 APs. My guess is they probably used an 8-port PoE switch, right? Because it was cheap network, obviously, and so now we've had to upgrade to probably a 24-port PoE switch. So, that's X amount right there that we've had to add. So, it's really hard to quantify just exactly how expensive this network has become. But it still is not going to work. Where we are failing requirements everywhere. If we just go look at our network health, like, oh, what a mess. I mean, we're failing requirements left and right. It's just awful.
Well, let's try and make this thing better. I know we're already getting close to the top of the webinar hour, and I want to make sure we save some time to the Q&A as well. So let's see. Okay, so let's go ahead. The next stage then is usually, all right, at this point, we've realized we can't fix this network ourselves by just throwing more APs at it. So we're going to kind of go back to the drawing board now and figure out, maybe consult an expert or something on this and say, all right, here's where we're at with things. We still got users complaining everywhere, and it's actually gotten worse since we've added more APs. Help us fix this. So what is the now starting to take more of a proper approach to this? So I think we've got enough APs, thankfully, at this point, right? So now it's just getting things in the right locations, getting things placed correctly, right? So now we're talking more of the moves.
Yeah. So should we go and move some APs around and count how many moves we do?
Yep.
All right. So everybody count with us. 1. No, you don't have to count with us. So we'll move 1. Actually, you know what I'm going to do is I'm going to turn, I'm actually just going to turn my visualization off, and I'm just going to move these around to where I think, and then we'll see how I did.
Oh, you know what you could use is the coverage planning mode.
Oh, I think you're right. So does that work when you move them? So go to coverage planning, and this is rad. So, okay, I moved 1, 2, 3, 4, so there's 5, and then we'll move 6. I'm going to put 1 down here. And we'll put 7 right here. I might move one of these around in a little bit, and then we'll move 8. Are you counting?
No. We'll get it close.
Count 9, 10. Yeah, 11, 12. You know what? We actually might. Well, no, I'm going to move 1 AP over here. I was almost thinking that we might be able to get rid of an AP, but I decided, we won't skimp out here.
Well, we already paid for it. We might as well use it.
Might as well use them. Okay, cool. Now, the other thing I'm going to do, Jerry, is, let's take a look at coverage and see how we're doing first, just to take a look at how things are going here. Okay, so if we look from a coverage standpoint, wow, this is looking a lot better right away. I mean, things are looking really good. We've got coverage in most corners of the building. There's a couple places here where maybe I can nudge an AP around a little bit to try to increase things, but we just did, I think we did 14 moves. I think we moved every single AP, so 14, we didn't move this lobby once. That's 13 moves in total that we just did there. Okay. And so now let's go check on requirements and see how we're doing. So I'll go to network issues and see, okay, so we are still running into this channel overlap and this signal to noise ratio issue. And I can tell you exactly why that is. If we turn on our tooltips, and if I hover my mouse over this pink area here, this is going to tell me how many APs are, first off, what issue we're running into here. It's channel overlap. And so I'll switch over to the channel overlap visualization. So basically what we're doing is we are now drilling down into that all the pink, all the magenta. We're going to drill down into this issue and find out more details about it. So when we do that, anywhere that's this kind of darker green, that's where we don't have any channel overlap. There's none. Anywhere that's kind of that yellowish green, that's where we're right on the edge. We have 2 APs sharing a channel there. And anywhere that's gray is where we have 3 or more. So we are failing our channel overlap requirement there. So how do we fix this? Well, right now we are using 80 megahertz wide channels. And on top of that, we're only using 180 megahertz channel down in Uni 1 and 180 megahertz channel down in Uni 3. And so what I'm going to do is I'm going to dial these channel widths back down to 40 megahertz wide channels. But Joel, narrower channels aren't as fast. Just wait, you'll see. And I'm going to open up a few more channels for this network. I'm just going to try these 6 actually and see how that works. And then we'll hit create plan to let Ekahau. Oh, go ahead. What's that, Jerry?
I got to say, Chris, I love your comment in chat. He says, once you get the channel overlap sorted out, then we'll find out that it's a multi-floor environment.
Yeah, and no, this is not a multi-story building, Chris. No, moving along swiftly.
It's so true, right? I mean, you look at it as like a 2D thing and you're like, oh, I've got the perfect channel plan. Oh, wait, there's floors above and below that I forgot to take into consideration.
But wait, there's more.
Yeah.
So we have mostly, I'm using 40s here. We could dial it back down to 20s and eliminate this channel overlap entirely. And if this is a multi-story building, we're going to have to do that. But for sake of example, I'll leave it at 40s here. So if we go back and look at our network issues now and see how we're doing, oh man, this is looking awesome. Things are looking much, much better. In fact, kind of from a statistics standpoint, we are passing requirements on 87% of our floor plan. In fact, you can make this even better. Down here in the corner, you see this stairwell. Well, what if that's just out of scope? What if this is not part of where we are providing Wi-Fi? Well, we could draw an exclusion area in here. And so I'll just draw in this area to say, hey, ignore this. That is not part of our scope of requirements. Now, if we go back and check on our requirements, now we've got it up to 89.2%. So I'll make my one political joke. We didn't actually change anything here. All we did is just change the scope of it, which made our numbers look better, which I'm pretty sure is what politicians do all the time. But there we go. So we're now meeting requirements on basically 90% of our floor plan. So, Jerry, is there anything else that we need to do for remediation on this network?
I mean, there's all sorts of things, obviously, that you can look at to further optimize this and tweak this and, making more like excluding the elevator shaft, those kinds of things to really dial us in until we get it exactly where we want it to be. But yeah, I think just, this is great for the time that we've got today. And I want to make sure we got some time for Q&A. And then we can go through anything else that you guys want to, if there's anything that we didn't get to in this. But just to add up the simple costs here that we've done so far, in my spreadsheet, I've got $6,500 for all the moves. And then for the ads, we've got another $3,500. So that right there, $10,000 just for this, smaller project and those changes, right? And that doesn't include the added, equipment costs and all that kind of stuff. That's just getting somebody to come back on site to make those moves and those ads. And then, yeah, obviously, we're talking about tweaking a lot of settings, a lot of changes, by chance you might be consulting with somebody else to help you with that, or that could just be a lot of time going back and forth and making changes to the configuration, surveying to validate it, making some more changes, going back and surveying to validate it. So there's the time aspect in there as well. And that's where that ROI calculator tries to kind of wrap all of that together for you to really show you the true cost that all this totals up to.
So a couple of questions that came in through the chat. A couple of people were asking, hey, how did you get that nifty pie chart? There is a button right here. That little button right there next to I drew an arrow pointing to it earlier. Hopefully that helps you see it. It's easy to miss, but that's how you get to the pie chart. And I use this like crazy. Yeah. This is one of my favorite things.
Yeah, it's like one of those hidden gem kind of things. I love I'm a statistical kind of guy. I like the statistics stuff. So I really appreciate that. And yeah, it is not very obvious that it's there.
Hey, Jerry, somebody in the chat says they want to buy Ekahau now. So mission accomplished. Cha-ching. Right. We're good to go. We're done. We're out of here. Sorry about your questions, guys. We're done. We did what we wanted to here. No, yeah. I'm kidding. So yeah, should we move into Q&A now, Jerry? What do you think?
Real quick, Bruce had a question about pie chart versus stack bar. That just depends on the visualization. Some are represented as a pie chart, some are represented as a stack bar. So, for example, like signal strength, you'll see that's a bar chart, and then the things like anything that can be represented as like a percentage will be represented as the pie chart, like the visualization percentage there. But yeah, here you can see there's your bar chart for the statistics.
And then when we switch back over to the network issues, then it goes back to a pie chart. So it just depends. Our R&D team, they took a good hard look at everything and determined, which would be the most useful for each one. So great. Okay. Well, question and answer time. Is that what time it is?
Let's go ahead and turn things over to Q&A. I haven't been watching it at all. I apologize if there's any questions in there. I don't actually see any questions in there. Look at that. I think we answered everybody's questions.
Oh, I see it. 5 of them that are open right now.
Do you?
Yeah.
Why am I not seeing that? Maybe it's because I dropped before that I lost them. Yeah, it looks like.
Let's see. I'm going to make you the host. I'm going to change the host to Jerry. Does it break anything? Oh, we're still here. Good thing. We're still here. You see him now?
I don't get to see him. I think because my Zoom crashed before, I must have lost the question. So I guess you're going to have to run with them.
Okay. Well, we're going to start at the very top. I'm going to start with Nick's question. Let's see. Nick asked earlier on, he says, we'd be addressing the point about Wi-Fi not being set and forget. What are good practices beyond the deployment of a well-designed wireless LAN? Great question. So yeah, the question is obviously Wi-Fi is not set and forget. What are good practices beyond deployment of a well-designed network? What do you think, Jerry?
Sorry, I was reading chat.
So Nick's question was, how do you address the fact that Wi-Fi is not a set and forget kind of thing? What are good practices beyond deployment of a well-designed network? Nick, I think some ones that I would add is, I try to keep an eye on my networks if I can get back out and give them a survey every now and then. See if any rogues have popped up. There's a couple of great visualizations in Ekahau that I like to use. And that sounds like a super salesy thing when I say it like that. I didn't mean it like that. But difference in interference, difference in signal strength, and difference in number of APs are great for comparative analysis. If you want to see like if an AP has gone offline at some point, that works out really well. That's one thing I would do is, go back and do kind of a checkup survey every now and then. And the nice thing about a continuous survey is, a building like this, man, we're talking about probably less than an hour to knock out a continuous survey here. I don't know. I hope that's a satisfactory answer.
Well, and I would pull the chat as well and see what you guys. So what I've been starting to see more and more of a trend, which I'm happy to finally see, is more maintenance being built into these networks, right? Not just waiting for something to break and people to complain, but actually like, especially in these really critical environments that we're talking about, like a healthcare environment or even like warehousing environments, these areas that are changing constantly, they're actually doing proactive maintenance now, and they're scheduling in maybe once a quarter, to actually do a proactive survey of the environment and see what the coverage looks like and see how things are changing. So you have this updated picture all the time from boots on the ground and what the clients are actually seeing the APs at and what the network actually looks like. So that would be definitely something I would encourage you guys to do if you're in those types of critical environments. Start to do these proactive, build that into your process, right, of these ongoing maintenance that you're going to need to do in these site surveys.
Yeah, absolutely. Yeah, Nick, I hope that's a satisfactory answer for you. Okay, I just have to get this one out of the way. It's the top upvoted question right now. Jared says, "How can I get a hat?"
Jared, upvoted question.
I don't know, man. You can't have mine. That's all I know.
Events are going to be your friend there. If we try to reserve some of this Ekahau swag, if you will, especially these kinds of swag items for like stopping by like an Ekahau booth at an event. I know we gave these out at Cisco Live last year. We're going to be at WLPC. We're going to have a bunch of people from Ekahau at WLPC, so there's a good chance you could get some cool Ekahau swag there. If you're not familiar with WLPC, I think there's a few slots left if you haven't registered for it. That's a wireless LAN professionals conference. Highly recommend checking that one out. We'll definitely be there.
Yep, that's the way. Definitely. Yeah, Eric says WLPC, can't wait. Neither can we. We're so excited about it. See, Xavier has a question. Do you see issues where MacBooks like to talk at really low data rates, like 6 megabits per second? We've tried disabling low data rates, but the PCAPs show them constantly trying to send at really low data rates. How do you fight current 2015 plus computers that talk at really low data rates? Xavier, I have not seen that specific problem. I mean, my MacBook right now is talking. So it says it's transmitting at MCS 6, and so yeah, I can't say I've seen that issue. So. Yeah, I don't know if
What
I can
was
help.
it again? The fighting with clients that want to talk at low data rates? Is that what it was?
Yeah, seeing MacBooks that will only transmit at 6 megabits per
MacBooks.
6 megabits per second. Yeah, so it sounds like those MacBooks have gotten really frustrated and are rate shifting way down and not rate shifting back up for some reason. So maybe a bug. But
Yeah. Yeah, I'd be interested. Anders says in chat that he thinks it sounds like a sticky client issue to him. So yeah, first thing would be to look at, what is the AP that they're associated to when they're transmitting at that 6 megabit per second. I mean, if they're, a good, nice and close to an AP, they certainly should be talking much faster than that. It's all about getting them on and off. The other things are, looking at things like, you can control some of that from an infrastructure standpoint by adjusting your minimum data rates, right? By raising that bar and saying, hey, if you want to play, if you want to be on this Wi-Fi, you need to be able to talk this fast. Raise that bar and say, if you're not going to talk this fast, you're not allowed on the Wi-Fi. That would be one way to kind of force the clients to talk faster by raising those minimum data rates.
yeah, Maxim has a comment too about 6 megabits per second being a mandatory rate. I mean, usually, I might say something completely wrong here, but I think I usually do mandatory rates of 6, 12, and 24. Oh, I don't know. So yeah, Jerry's giving me the look here, so I might not be.
That's the look.
Yeah, just don't listen to any of that.
Yeah, data rates gets tricky, right? I mean, you got to design for the data rate, right? Or at least survey and validate that you can support certain data rates. You don't want to just blindly go and crank up the knob of, saying everybody needs to talk at 54 megabits per second or you're not allowed on the network. If your network isn't designed to support that or your clients don't support that, you're going to have, some bad experiences out there. So yeah, making sure you have the appropriate SNR to support talking at those types of speeds. And then you can start to slowly turn up that knob and see, where the clients, where you can kind of have that balance and make sure everything's talking at the fastest rate possible without breaking anything.
Cool. Okay, so we probably have time for. I think we could probably do one more question before we shut it down here and let everybody get on with their day. Yeah, I see. Like Hans says, thanks guys. Till next time. Thanks Hans. Thanks for being here. Let's see. So Fabiano had a good question earlier that I think is really pertinent to this topic that I want to cover here. He says for 3 floors using voice plus data, 2.4 is turned off. Only they're using 3802Is in dual 5 gigahertz mode. What would be the minimum distance between APs and how much power in milliwatts or dBm? Good question, Fabiano. I'm going to give the Sam Clements answer here. I know it's kind of a cop-out, but I'm going to do it. I'm going to say it depends. People often try to, I've heard a lot of people say, well, you just need to do 1 AP every 1,500 square feet or whatever, I do not like blanket statements like that because I don't think they're realistic. I think it depends on the environment. Everything is dependent on the environment, the clients you're supporting, the level of signal strength that you're going to be providing, things like that. And so there's really no way to give how far apart should APs be. Now, one rule of thumb for sure, don't put APs right next to each other. We've all been somewhere where you look at the ceiling and there's like 2 APs, like, a meter or 2 apart from each other. Don't do that. There's some big reasons why that's a bad idea. But if you see someone giving you these blanket statements of, 1 AP every 1,500 square feet or 1 AP every 2,000 square feet, run. That's not a good way to design a network. It's all about determining requirements. It's all about validating those requirements, whether it be performing a predictive model or doing an AP on a stick survey to see what your coverage cells look like, testing clients, making sure that they're able to talk back to the AP, things like that. So I don't know, Jerry, anything to add to that?
Yeah, I would just say if you have Ekahau, obviously an easy way to overcome that is plug that into Ekahau. Take that kind of best, I wouldn't say best practice, take that practice putting in the AP every so many thousand square feet or whatever whatever that standard is, and see what it looks like in Ekahau. Just do a quick simulation of it. If you don't have Ekahau, here, let me pull this up here. So you can go to ekahau.com/evaluate and request a fully functioning eval license of Ekahau and model it up in an eval version of it, just to sell your boss or whoever it is on hey, here's what happens if we deploy this using this kind of standard and not actually design it properly, and then do a comparison and say, okay, if we actually design it properly to these specific requirements, here's how many APs we'll actually need and where they should be installed. Eval license is fully functional. The biggest limitation that you're going to have, I should clarify that. Eval license is that when you request an eval license and you're sent to it, there is a way you can just download a limited eval license from our website just to play around with the tool a little bit. That's pretty limited. It doesn't allow you to save anything. A fully functioning eval license, by filling out that form, will allow you the full functionality for a number of days that you can use. The big limitation there that you're going to have is you're going to be restricted to just your internal adapter to do any type of actual survey work. You're not going to have a sidekick with a spectrum analyzer and the hardware that really enables the advanced functionality there. But for planning simulation, you'll have all the functionality that exists in the full product in the eval.
And I think on that note, it's time to end. I think we're right. We're at 11:05, so we're about 5 minutes over the top of the hour here. And so I think we should probably go ahead and get this shut down. So, hey, everyone, thanks for being here. Jerry and I really enjoy giving these webinars. We enjoy hanging out with you guys. We enjoy the questions in the comments. Sorry that we didn't get all the questions here, but we really hope that you enjoyed this presentation. Jerry, go ahead.
Lasse had a question in there about if we'll be at Cisco Live, which is coming up here in just a couple of weeks as well, right around the same time, I think, as WLPC. Joel and I will not be there, but we do have a booth, and we'll have quite a few people from Ekahau that will be at Cisco Live in the EU there in, I think it's Barcelona is Cisco Live. So yeah, if you're going to Cisco Live in the EU there, definitely stop by the Ekahau booth. Hopefully they'll have some cool swag for you there.
Yeah.
No guarantees, but yeah, usually they always try and have some awesome stuff for our customers there.
Yeah, don't quote me on this, but I'm pretty sure that Nick Turner is going to be there. Nick is one of our absolute best, and he's just one of the best in general. So be sure to say hi to the team while you're there. Nick, probably UC. I think Nick and UC will be there. So yeah, great. Well, let's go ahead and shut this down. Hopefully, we'll see some of you at WLPC, and maybe see you, not Jerry and I, but we'll see you at Cisco Live as well. Thanks for being here for this webinar, everyone. We really appreciate it. We appreciate you taking the time. We will post this, the recording of this, within 24 hours. This will be available on the webinars page on our website, and we will look forward to seeing you in a future Ekahau webinar. See you next time.
Thanks, guys.